Okay, what we're looking at here is Module 6, Lesson 1, Modeling Linear Relationships. This is going to be a bit of a review. We did this lesson a while back, but the word problems and the content of it is pretty important, so I thought it'd be a good way of kind of jumping into this distance learning program we're trying to get up and running. Heading into this, just know that at any time you can click pause, you can go back. If you have any questions, please go to the comment section and type those questions in. Occasionally I will be not fully solving things and encouraging y'all to go into the comment section and put your answers in after you find a solution. Also, if I'm moving too fast, make sure you know you can click pause and you don't have to yell at your screen. Oh wait, don't scroll down, don't scroll back up, okay? Ha ha ha. Okay, so this first section, lesson 1, modeling linear relationships. I'm going to break these down into smaller parts. We're not going to do the whole lesson in one video. That way, nobody gets overwhelmed and you can easily find where you were working. This is a bit of a lengthy one, so let's just jump right into it. Okay, so lesson 1, modeling linear relationships. First, I'd like to review the outcomes and objectives for this lesson. I will determine a linear function given a verbal description of a linear relationship between two quantities. First off is that relationship between two quantities. We are very much, we're very much talking about ratios when we compare quantities, and there are ratios in all of the work we've been doing with this material, okay? I will interpret linear functions based on the context or plot of a problem. I'm very much borrowing from ELA here when we use the word plot. What's the storyline? What's going on? All of these verbal descriptions are very much going to be presented to us as short stories, very, very short stories, and we're going to use our math to navigate the short stories and solve the conflict, if you will. I will graph linear functions by constructing a table of values, plotting points, and drawing a line. Okay, so we've done quite a bit of work with this, and we're going to get a little more reinforcement on that right now. I do want to emphasize this word that keeps coming up that we should all be very familiar with by this point, and that is linear. Okay, when we're dealing with linear functions, we're dealing with straight lines, we're dealing with a constant rate of change, okay? And we're not so much talking about constant of proportionality, okay? Which would be y is equal to k times x. That is not what we're dealing with these. We are talking about y is equal to mx plus b, okay? Where we have a y value represents one quantity, and x value represents another quantity, and we have m and b, where m is going to be some kind of ratio. M is going to be our constant rate of change, okay? And b is going to be our y-intercept, and depending on the situation we're working on, that y-intercept is going to have a meaning that aligns somewhere with the story. Okay, so now that we have our objectives covered, I just want to jump right into the classwork example 1, logging on. Lenore has just purchased a tablet computer, and she has considered purchasing an internet access plan so that she can connect to the internet wirelessly from virtually anywhere in the world. One company offers an internet access plan so that when a person connects to the company's wireless network, the person is charged a fixed access fee for connecting plus an amount for the number of minutes connected based on a constant usage rate in dollars per minute. I want to hold up right there because there was a lot of information in that one sentence, right? And specifically the second part. So the plan says that when a person connects, some kind of fee service kicks in, and that is that person is charged a fixed access fee for connecting plus an amount for the number of minutes connected based on a constant usage rate in dollars per minute. This second part, especially right here, constant usage rate in dollars per minute. That is very much ratio language. And that's what we've been focusing on, is how when we hear language like that, ratio pops into our head. Okay? And because there's a fixed access fee and because there's a constant usage rate in dollars per minute, we are dealing with y is equal to mx plus b. Okay? Lenore is considering this company's plan, but the company's advertisement does not state how much the fixed access fee for connecting is. I wonder at one point if we're going to be asked to identify what is that fixed access fee for connecting. Okay? Nor does it state the usage rate. However, the company's website says that a 10-minute session costs 40 cents, a 20-minute session costs 70 cents, and a 30-minute session costs $1 or 100 cents. Lenore decides to use these pieces of information to determine both the fixed access fee for connecting and the usage rate. Okay? I really want to examine these. Do we have this? Dollars per minute. And do we have it how many times? 3 times. When minutes are 10, cents are 40. When minutes are 20, cents are 70. And when minutes are 30, cents are $1. So before we even move any further, I want to kind of summarize what we've been able to pull out of this. We know that we will be dealing with y equals mx plus b, and because of that, we will have to have y represent something, we will have to have x represent something, we will have to have m represent something, and we will have to have b represent something. Okay, so y, x, m, and b. And also, we have been given 3 ratios. Okay, and those ratios are comparing minutes to dollars. And when minutes are 10, money is 40 cents. When minutes are 20, money is 70 cents. And when minutes are 30, money is $1. And a number of us might already be recognizing a bit of a pattern in there. When we increase minutes by this amount, there's a corresponding increase in cents. Okay? So if you need to get some more of this information down, go ahead and click pause, but I'm moving on. All right? So exercises 1 through 6. Okay, Lenore makes a table of this information. Very good, Lenore. Whenever you're presented with a great deal of data, you might as well go ahead and make a table and help you start organizing it. And a graph where a number of minutes is represented by the horizontal axis and total session cost is represented by the vertical axis. When we're talking about a horizontal axis, are we talking about X? And when we're talking about a vertical axis, are we talking about Y? So looking back at, and I'll just write it down here to make things easier, Y is equal to mx plus b, and we know we need to identify what Y represents, X represents, M represents, and B represents. Y is our cost, X is our number of minutes. And we see that right there, because they put number of minutes on the x-axis and they put cost in dollars on the y-axis. Okay, plot the 3 given points on the table. These 3 points appear to lie on a line. Okay, so we have, if this is x and this is y, we have 3 x, y coordinates, correct? Okay, so let's look at those three. When X is 10, Y is 40 cents, and they were nice enough to give us a little cheat. And how do we know that cheater space, and you see it by the 20, you see it by the 30, right? How do you know that cheater space is in the correct place? Well, 40 cents, and we have a distance from 0 to 50 cents. Half a dollar is 50 cents. So we can divide that into 1, 2, 3, 4, 5, right? And at 40 cents, and I could have done a little bit better job there, I guess. So let me do that. Okay. 10 cents, 20 cents, 30 cents, 40 cents. And so at 10, 40 cents, 10 minutes and 40 cents, we put a point. And the same thing at 20 minutes and 70 cents, we put another point. And at 30 minutes and $1, we put another point. Okay? And if you want, pause the video, use the lines on your loose leaf or in your notebook to create a table, and just do your best to make it as precise as you can. But we know that if we connect these lines and we keep that line straight, it does not pass through 0, 0, because we know we're not dealing with y equals mx plus b. Okay? And so this is a straight line. This is linear. Okay? What information about the axis plane suggests that the correct model is indeed a linear relationship? Okay? So we've plotted those things. All right? And if we look at number 2, the rate of change describes how the total cost changes with respect to time. A, when the number of minutes increases by 10, e.g. from 10 to 20 or from 20 to 30, how much does the charge increase? Let's go to our table, and we're looking at when we go from here to there and there to there, that is plus 10. Now, what is the distance? What is the difference of 70 and 40? How much has it increased? Well, 70 cents minus 40 cents is 30 cents. So it's plus 30 cents, and 70 cents plus 30 cents is $1. And I know more than a few of y'all are probably chomping at the bit right now to say that, hey, we just did change in y over change in x. Correct? Change in y over change in x. And more than a few of y'all are saying change in y over change in x can be calculated as y of 2 minus y of 1 over x of 2 minus x of 1. And to calculate that, all we need is two corresponding xy coordinates. So if we look at, I'll change the color here. If we look at this one and we look at this one, we can say that this is coordinate 1 and this is coordinate 2, making that y of 2. So 70 cents minus y of 1. This is y of 1 minus 40 cents over 20 cents x of 2 minus, 20 minutes minus 10 minutes is going to be equal to 30 cents over 10 minutes. So that when minutes is increased by 10, it comes with a corresponding increase of cents by 30. Okay? Another way to say this would be part B. Another way to say this would be the usage charge per 10 minutes of use. Use that information to determine the increase in cost based on only 1 minute of additional use. In other words, find the usage charge per minute of use. Okay, so we have, change the color again. we have a ratio. And by the way, is all of this m is equal to? Are we identifying m right now? And so we have a ratio of m is equal to, oops, right? And that's not a unit rate, that's per 10. So to find per 1, we just need to solve that division problem, and we will get cents per minute. And we have identified m. So if we go back to our y equals mx plus b, we know that y is dollars, x is minutes, m is change in y over change in x, y of 2 minus y of 1 divided by x of 2 minus x of 1. We know that that is now 0.03. And we have one more component to identify, okay? So far for part A, we found that the change in y over change in x is 30 cents over 10 minutes. And to calculate a unit rate, to calculate that m value, 3 cents per minute. 30 cents per 10 minutes is 3 cents per minute, okay? So now we are going to move into 3. The company's pricing plan states that the usage rate is constant for any number of minutes connected to the internet. Well, that's a definition of constant. Very good. In other words, the increase in cost for 10 more minutes of use, the value that you calculate in exercise 2, is the same whether you increase from 20 to 30, 30 to 40, etc. Using this information, determine the total cost for 40 minutes, 50 minutes, and 60 minutes. Record those values in the table and plot the corresponding points on the graph in exercise 1. Okay, so let's go back to the table. Well, let's continue our pattern. $1 plus 30 cents is $1.30. $1.30 plus 30 cents is $1.60. $1.60 plus 30 cents is $1.90. Okay, and so we go to our graph, and at 40, nice little cheater mark right there, 40 is $1.30. 50 is $1.60, and 60 is $1.90. And we can connect those dots, and we get ourselves a very nice straight line that picks up where we've left off. And we can even continue it out because that's what I'm doing. I'm sure there are times when you will be on the internet for longer than 60 minutes. Okay. And we have found that at 40 minutes, okay, $1.30, 50 minutes $1.60, 60 minutes $1.90. Okay, using number 4, using the table in the graph in exercise 1, compute the hypothetical cost for 0 minutes of use. What does that value represent in the context of the values that Lenore is trying to figure out? Okay, hypothetical, okay, not necessarily true, but you know, there's theory. What is it theoretically? Okay, so let's look at y. As we add 10 minutes, we add 30 cents. So plus 10 plus 30 plus 10 plus 30, right? Plus 10 on the x is plus 30 cents on the y. Can we turn that pattern around? When we take away 10 minutes, what do we take away? 30 cents. If you're adding 30 cents to increase, you're subtracting 30 cents to decrease. So this is going to be 10 cents. Okay? So when x is 0, y is 10 cents. Okay? So this hypothetical cost. And let's discuss that for a second, okay? She hasn't used the internet, but has she paid any money? So we can say when x is 0, or for the context, when minutes are 0, cents our cost is 10 cents, meaning it costs 10 cents to access the internet. And I don't know if this is necessarily just hypothetical, okay? It could also mean that she sits down to her tablet, she opens up her web browser, maybe this screen pops up and says, hey, you're about to access the internet, which you're going to have to pay for by the minute. Okay, do you wish to proceed? She clicks yes, and then all of a sudden she hears her mom calling from across the house saying, hey, did you do the dishes yet? No, I didn't. And being the good daughter that Lenora is, she X's out of the browser almost as soon as she got in, split second later. And then the next time she looks at her account, she sees that she was charged 10 cents. So is it possible this 10 cents was just the cost of accessing the internet even though she didn't use any of it? That's aggravating, but maybe it's not as hypothetical as the word problem makes it out to be. Okay, so number 5, on the graph in exercise 1, draw a line through the points representing 0 to 60 minutes of the use under this company's plan, which we've already done. The slope of the line is equal to the rate of change, which in this case is the usage rate. Okay, so if we go back and we look at it, yeah, we have a nice sloped line from 0 to 60, and right here is 0, 10 cents. And that is what? B. That is our y-intercept. That is that initial fee for accessing the internet, okay? In part, so 6, using x for the number of minutes and y for the total cost in dollars, write a function to model the linear relationship between minutes of use and total cost. And we can simply do what? We're going to use the format of y equals mx plus b, where y is cost, x is minutes, m is cost per minute. In this situation, it's 3 cents. And b, okay, we know from our graph and our table that is 10 cents. Okay, but this right here, let's focus on this right here. Let's say we didn't have the table and we didn't have the graph, okay? Because remember, we've learned some skills from now. All right, when we look at this, when we have it fully built, this is a function. It is a machine for taking our x values and turning them into y values. So you input an x, you output a y. Okay, so when this is up and running, it will identify all of this. Okay, we'll take all those x's and turn them into y's, and it'll take all those y's and turn them into x's. So, do we have corresponding? Do we know y? So if you don't, so the purpose of a function is when you have an x and you don't know a y, or you have a y and you don't know an x, you can use that function to identify it. But if you know an x when you know a y, can you go ahead and just plug those in and you have one unknown left? Let's say that let's pretend hypothetically this is still unknown. So let's look at this first one right here, 10 and 40 cents. Okay, so we're going to say x is 40 cents. Sorry, y is 40 cents, x is 10 minutes, and we don't know that. So we're going to put our function together. We're going to say is equal to 3 cents per minute times 10 minutes plus b, as of yet unknown. And using inverse operations, we are going to get that b by itself. B is equal to 10 cents. Okay, and now we can complete our function. Y is equal to 3 cents per minute times x plus. So we take all of that, that graph, that table, we take all of that and we turn it into this function, okay? And what I would like y'all to take a shot at in the comment section, mom says that you have only $10 to spend on internet access. How much time can you spend? And you have a project that you're going to need 2 hours of internet time. How much money do you need to get from mom? Okay? So in this first situation right here, call it situation 1, and then situation 2. In situation 1, mom has said your allowance for internet usage is $10 to use on internet. How many minutes can you go online? Okay? And the second situation is you know you need to complete a research project and you'll need about 2 hours. So we'll just say 2 hours of internet time, 120 minutes. What should you ask mom for? What is your why? How much money will you need? Okay, so maybe take a shot at them, put them in the comment section below, and I'll get back to y'all with part 2 as soon as I get it completed.